guys, welcome back. This is Sakshi Kakre, and in today's session we are going to see what is sorting. So let's move to the introductory part of sorting. So firstly, sorting generally refers to arranging a set of data in some logical order. That is, it may be in ascending order or in descending order. Again, for example, a telephone directory can be considered as a list where each record has three fields, that is, name, address, and phone number. Being unique, phone number can work as a key to locate any record in the list. Again, sorting is among the most basic problem in algorithm design. So while studying data structure, we should know the different types of sorts present in data structure. We are given a sequence of items, each associated with a given key value, and the problem is to rearrange the items so that they are in an increasing or decreasing order by the key. Or else, we can say that if each element present in the array contains all the elements which are present at the left side are smaller than that number, and if all the elements present in the right side of the element are greater than that number, then we can say that the array is a sorted array. So the method of sorting can be divided into two categories. The first one is internal sorting, whereas the second one is external sorting. So let's see what is basically an internal sorting. If all the data that is to be sorted can be adjusted at a time in main memory, then internal sorting methods are used. All the examples which we are going to study in today's session are of internal sorting. The next is external sorting. When the data to be sorted can't be accommodated in the memory at the same time and some has to be kept in auxiliary memory, then external sorting methods are used. Let's move ahead and see what are the different types of sorts present in data structure. So there are many sorts like bubble sort, selection sort, insertion sort, then quick sort, then radix sort, bucket sort. Again, there are more, that is heap sort, merge sort, and counting sort. So let's move ahead towards the first sort which we are going to study in today's session. And the first one is bubble sort. So what is it? Bubble sort is a simple sorting algorithm that repeatedly steps through the list, compares adjacent elements, and swap them if they are in the wrong order. Again, the pass through the list is repeated until the list is sorted. So don't worry guys, in the next slide we will see its working in detail. The time complexity for worst and average case is big O of n square. Time complexity is basically the time required for the algorithm, and the space complexity is big O of 1. Space complexity is basically the memory or space required for the algorithm. So let's see the working of bubble sort. So the first step is, let us suppose that my array is consisting of these elements present into it. That is 4, 9, 5, 1 and 0, and we need to make this array as a sorted array. So when we are using bubble sort, at that time we need to compare the elements which are present at adjacent memory location, or we have to start with the 0th index. That in the first case we are going to compare the element which is present at 0 index position and first index position. So as in this case 9 is greater than 4, so there is no need to swap the elements. So here no swap takes place. So this is basically the first iteration. In the second iteration, the element present at the first index position and second index position, that is 9 and 5, are compared with each other. So in this case, as 5 is smaller than 9, so we need to swap the elements. So here swap takes place. So this is basically the second iteration. Again, in the third iteration, we are going to compare the elements which are present at the second and third index position. That is, in this case, 9 and 1. So again, as 1 is smaller than 9, so in this case, we need to swap the elements. So this is basically the third iteration. And in the fourth iteration, that is at the index position 3 and 4, again we need to compare the elements. In this case again, as 0 is smaller than 9, we need to swap the elements. and this is basically the fourth iteration. So at last we get this array, but this array is again not sorted. So we have to follow the same steps again to make the array as a sorted array. So basically this was the step 1 for bubble sort. Let's move to the next step, that is step 2. In this case we are having this element which was our last array in the last slide. So again we need to compare the elements at 0 and first position, that is 4 and 5. In this case, as 5 is greater than 4, so here no need of swap. So this is the first iteration. Again in the second case, we need to compare the elements which are present at first and second position. So here as 1 is smaller than 5, so we need to swap the elements. And this is the second iteration. Again we have to move forward and check the condition for the second and third index position. So as 0 is smaller than 5, again we need to swap the elements, and this is the third iteration. Again for the fourth iteration we need to do that, but in this case as 9 is greater than 5, so there is no need to swap the elements. So this is the fourth iteration, and at last we get this array. But again this array is not completely sorted, so we have to go for the step again. And in the next step, that is step 3, we have to perform the same operation. That is, we have to compare the element which is present at 0 and first index position. So in this case, as 1 is smaller than 4, so we need to swap the elements. And this is the first iteration. So again, we have to compare the elements at first and second position. Again, 0 is smaller than 4, so we need to swap the elements. And again, we have to go for the next step. And at last we get this as our array. But again this array is not sorted, so we have to go for the step 4. That is, this was the last array which was present, we have found. And again we have to compare the elements at 0 and first position. So in this case, as 0 is smaller than 1, so here swap takes place. And at last we get the array which is now, we can say that it is a sorted array. So this is how the bubble sort works. Let's move ahead and let's see the next sort, which is the selection sort. Selection sort performs sorting by repeatedly putting the largest element in the unsorted portion of the array to the end of this unsorted portion until the whole array is sorted. Again, the time complexity for worst and average case is big O of n square, whereas the space complexity is big O of 1. So let's see how selection sort exactly works. So the first step is that, let us suppose that I am having 4 elements into my array, that is 4, 9, 5 and 1, and I need to swap these elements. So in this case, what happens in selection sort? First, I am taking the element which is present at 0th position, and after that I am going to compare the same element with the first, second, third and fourth element. So in this case, my element present at the 0th index position is 4. So firstly, I am going to compare that element with the element present at the first index position. So while comparison between 4 and 9, 9 is greater than 4. So here no need of swap takes place. In the next case, here I am again taking the element 4 which is present at the index position 0, and I am comparing that element with the element which is present at the second index position, that is 5. So in this case, as 5 is greater than 4, so here no need of swap takes place. Again in the next case, I am going to compare the element of 0th index position, that is 4, with the element 1. So as 1 is smaller than 4, so here swap takes place. And at last we get the array as 1, 5, 9, 4. So now 1 has become fixed. Now we will move to the step 2, and in this case we are going to compare the elements of first index position with the remaining index position. That is, in this case I am going to compare the element 5 with 9 and 4. So in this first case I am comparing the element 5 with 9. So as in this case 9 is greater than 5, so here no need of swap takes place. Again, in the next case, I am going to compare the element 5 with the element 4. So here, as 4 is smaller than 5, so swap must needed. So here swap takes place and at last we get the array as 1, 4, 9, 5. Now in this case 1 and 4 are sorted. We can say that 1 and 4 elements are sorted. So again we have to go for step 3. And in step 3 we are going to compare the element which is present at second and third index position. So as 5 is smaller than 9, so we need to swap the elements. So after swapping the elements, we get the array as 1, 4, 5, 9. And now we can call this array as a sorted array. So this is basically how selection sort works. Let's move to the next concept or next sort, that is insertion sort. So what is it? This is an in-place comparison based sorting algorithm. Again, here a sublist is maintained which is always sorted. The time complexity for best case is big O of n and for worst case it is big O of n square. And the space complexity is again big O of 1. So let's now see how insertion sort exactly works. So in this case, I am having the elements 4, 9, 5, 1, 0 into my array and I need to maintain the elements in a sorted array. So in this case, we are having a key value. So in this case, I am comparing the element 4 with the element 9. As 9 is greater than 4, so here no need of swap takes place. Again, in the next case, what happens is that I am going to make the leftmost part of my array as sorted one. So in this case 5 is my key value. So in the left part 5 must be inserted between 4 and 9. So it gets inserted between 4 and 9. And after getting inserted, we get a sorted array in our leftmost part, that is 4, 5 and 9. Now we can call as 4, 5 and 9 are my sorted array or sorted elements. Again, in this case now the key value is 1. But seeing at the left part, we can say that 1 must be entered at the 0th index position. So in this case, the element 1 is placed at the 0th index position, and again now the leftmost part has become sorted part, or we can say that the elements are in a sorted. Again in this case the key value for our sort is 0. So seeing at the leftmost part, the 0 element should be present before 1, or we can say that it should be present at 0th index position. So we need to keep the element 0 at the 0th index position. And finally, we get the elements as 0, 1, 4, 5 and 9, which is our sorted array. So this is basically how insertion sort works. And the elements which we have taken are called as key elements. Let's move ahead to the next sort in our session, which is the radix sort. So what is it? Radix sort is a sorting technique that sorts the element by first grouping the individuals of the same place value. That is, it may be units place, tens place or hundred place. Suppose we have an array of 8 elements. First, we will sort elements based on the value of the unit place. Then, we will sort elements based on the value of 10th place. This process goes on until the last significant place. So let's see this radix sort with an example. Let us consider that I am having these elements, that is 121, 001, 432, 023, 564, 45 and 788. This much elements are present into my array and I need to sort these elements. So firstly, we have to check for the units place elements. So in this case, the unit place elements are 1, 1, 2, 3, 4, 5, 8. So we have made changes with the units place elements. That is, we have made the unit place element into a sorted order among all the elements which we were having. Again, in the next place, we are comparing the elements which are present at the tens place and we are making them into a ascending order. So, we get elements as 0, 2, 2, 3, 4, 6, 8. So, after this, we need to compare the elements for 100 place. And after doing that, we get the elements as 0, 0, 0, 1, 4, 5, 7. And now, seeing this, we can say that the elements into my array are sorted. As here, you can see that 1, 23, 45, 121, 432, 564 and 788 are sorted or are in ascending order. So we can say that now the array is a sorted array. So this is how sorting according to units, tens and 100 place digits. That is, it is a radix sort. So let's move ahead to the quick sort. So what is a quick sort? Quick sort is basically a divide and conquer algorithm. It works by selecting a pivot element from the array and partitioning the other element into two subarrays according to whether they are less than or greater than pivot. So let's see the quick sort with an example. So what is a quick sort? Let us suppose that these elements are present into my array, that is 7, 1, 3, 5, 2, 6 and 4, and I need to sort the elements present into that. So what I will do, I will select a pivot element. In my case, I am considering the element of the last as a pivot element. So in this case, 4 will be my pivot element. After that, what I am going to do is that I am going to divide my quick sort, or we can say that I am going to divide my array into two parts. Basically, we can see that what I have done over here is that my element 4, I have placed it at the center. And after placing the element 4 at the leftmost part of that element, I have placed all the elements which are less than 4. And in the right part of my array, I have placed all the elements which are greater than 4. So we have just divided the array into two parts. So the first two parts are the left of 4 which is smaller than 4 and the right of 4 which is greater than 4. So after dividing these elements, what I have done is that I have taken the leftmost part of the 4. Again, what I have done over here is that I have again taken here a pivot element and I have divided again that into two parts. In this case, my pivot element is 2. So I have divided that into two parts. In the leftmost side of 2, all the elements which are smaller than 2 are present, and in the rightmost part of 2, all the elements which are greater than 2 are present. So again, the remaining part is of right of 4, which we are not taking in this part. But we need to consider the pivot element as 6 for this case, as we are taking the elements which are present at the last as a pivot element. So what happens over here is that in the first section, which is the leftmost part of 4, now only 1 is present in the left part of 2, and when one element is present in the array, then we can say that the element is a sorted element. So here in this case, 1 and 3 are now sorted element, and earlier 2 was sorted. So now 1, 2, 3 and 4 are sorted elements. So in the next case, that is, we are having the pivot element as 6. So in the left part of 6, we are having the element that is 5, which is a smaller than element 6. And in the right side of 6, we are having the element which is greater than 6, that is element 7. Now the left part of 4 is sorted, which we have done in the earlier part. So in this case, now we can say that the right of 4 is also a sorted, and the left part of 6 is smaller, that is 5, and the right part of 6 is 7. As 5 and 7 are the only one element, so we can say that they are sorted element. So now we can say that the whole list is a sorted list. The left part of the 4 as well as the right part of 4 is now a sorted. So this is how the quick sort works. And this array is now has become a sorted array. So this was all about today's session. Hope that you guys are now cleared with the concept of sorts. So thank you for listening to the session. Thank you.